What we have learned in the last period? क्या सीखा था हमने पिछले क्लास में? Yes. बोलो. We have started regarding the atomic models, right? We have seen regarding the structure of the atom or the atomic models, right? What kind of the atomic model we have done? That is nothing but the Bohr's atomic model, right? Now see, I'm going to show you one video so that you can able to understand how is the Bohr's atomic model. Okay. In the last period, in the last class also I have shown you regarding this video. Now we have to start with this video. Use skill to implement information. See here. Are you able to see the video?
Are you see the video?
And why are we saying so? We know that any charged object which revolves in a circular motion gains acceleration gradually. Similarly, if the electron is moving fast in a circular path, then it will also gain acceleration. And on gaining acceleration, it's bound to generate energy in some form. Now, if it continuously keeps radiating energy, then ultimately all the energy of the electron will get over and will fall into the nucleus. This would result in high instability of the atom. But wait a second, all these things do not happen in an atom. And how do we know this? Because in nature, all the atoms are stable. That means the hypothesis put forth by Rutherford was also incorrect? Not really. The hypothesis just needed right modifications. These were made by the next legendary scientist in our list called Niels Bohr. He made a few additional explanations to describe the atomic structure. The postulates put forward by Niels Bohr were as follows. Firstly, only certain special orbits called discrete orbits of electrons are allowed inside the atom. Secondly, while revolving in these discrete orbits, the electrons do not radiate energy. Now, these points definitely tell us why an atom is so stable. But what exactly are these paths or orbits in which the electrons revolve around the nucleus? Let's understand with an example. Do you know how our solar system is? Yes, it appears somewhat like this. Now here, the sun is stationary at the center while the planets revolve around it. But have you noticed that the planets always revolve in fixed paths? You never find any planet jumping to a different path all of a sudden, right? They always encircle the sun in defined paths. In a similar way, we have the atomic structure. The nucleus acts like the sun located at the center, and the electrons are like planets which revolve in fixed defined orbitals. These electron orbitals are referred to as shells or energy levels. Now, the name energy level gets us to an important concept. Niels Bohr suggested that the electrons revolving in these orbitals do not radiate energy. This is justified when we use the term energy levels, because it indicates that each shell has got a defined energy level. That means when the electrons revolve in these shells, they do not liberate any form of energy. And how do we name these shells to indicate their position? Simple. Beginning from the ones in the nucleus, we name them as the K shell, L shell, M shell, N shell, and so on. Yes, K, L, M, N, and so on. And what if we want to number them? In that case, we use the letter N in lowercase and write them as N equals 1, N equals 2, N equals 3, and so on, beginning from the one next to the nucleus. So we can name them alphabetically, or we can even number them. With all these theories and points known, we now know the structure of a typical atom completely. The nucleus contains positive protons and the electrons revolving around in its orbitals. Is that how an atom is structured? Not really. We still have one more subatomic particle left. And what and where can it be? Let's find that out. It was around the year 1932 when a famous English physicist, Sir James Chadwick, found the third subatomic particle. He found that the particle had a mass almost equivalent to that of the proton. And what about its charge? Astonishingly, it had no charge. Yes, the particle was neutral. The particle was later named as neutron, denoted by the letter N. Thus, now we have the complete design of an atom. In the center lies the nucleus having positively charged protons and neutral neutrons, while the negatively charged electrons revolve in fixed orbitals around the nucleus. But how exactly are the electrons distributed in the respective orbitals? Is there a way to find out the maximum number of electrons that one orbital can contain? Or is it that the electrons are randomly scattered in orbitals? Let's find out the answers to these questions in our upcoming video.
Now, children, listen. See here. I have told you that what is mean by the. We have started. I have told you that how many orbitals are there, how the orbitals are having the different kind of the electron, maximum number of electron, how it can be get calculated. We have seen all these things in the yesterday's period, right? We have seen that there are the orbitals known as the A, L, M, like these orbitals are there. They can be denoted by their numbers also. And these numbers are nothing but the n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, like these one. And the maximum number of the electron, those are present within these shells. These are nothing but, if suppose we are taking the K shell, whether this font is visible to you all, or I will increase the font. Yes, shall I increase the font? I already increased. Now see here, K shell, it is having how many electrons within each one? K shell is having the 2 electrons within each one. If we consider one more kind of the shell, that is nothing but the L shell, which is the second shell, it is having 8 maximum number of the electrons within each one. If suppose we are considering the M shell is having the 18 number of the electrons associated with each one, maximum number of the electrons are there. If suppose we are considering the N shell, it is having how many electrons? 32 electrons within each one, in this way. And also we have learned that how is the energy of these energy levels, right? How is the energy of these energy levels? How is the energy? K is having the less energy than M is having less energy than N is having, K is having less energy than L is having less energy than M is having less energy than N might be having the less energy than O, it is having less energy than P, it is having less energy than Q. In this way, have you followed this one? समझ में आ रहा है? Now we have to discuss that how the electron distribution it is to be carried out. We have to discuss regarding the electronic or electron distribution. We have to discuss electron distribution. Now see, before we see the electron distribution, now you come to know that how is the atomic structure given by the Bohr. At the center, there is a presence of the positively charged nucleus, which is containing the proton within each one. Actually, Bohr has been given the atomic structure in the year 1913, right? He has given the atomic structure in 1913. At that time only, he knows only the 2 subatomic particles. Only 2 subatomic particles are known. Which are them? Which are nothing but the, which are 2 subatomic particles are known, that are nothing but the protons and that of the electrons. Protons and electrons. These are the 2 subatomic particles are to be known. Now, After in the year 1932, James Chadwick, name is James Chadwick, has been invented the presence of, has discovered the third subatomic particle, discovered third subatomic particle known as subatomic particle known as neutron, right? Known as the neutron. Now, what is the speciality of this neutron? Actually, neutron is chargeless particle. Is a chargeless particle. It is not having any kind of the charge, but it has same mass,
जेवण कसं आहे मांडीवर परत घेऊन जेवण
same mass.
गणपत तुला तर हा फोन कधी
Yourself.
लागला
करायला काय खाली गडाव टाका
ती मम्मी कितीला द्यायला माहितीये का एवढा गट्टा असला तरी एक आईस्क्रीम नाही म्हणलं बाबा
Don't cause the chaos in the class. Please mute yourselves. Only unmute yourself whenever you are necessary to talk. Now see here, we are discussing about the neutron. Neutron is chargeless particle, but it has same mass as that of proton. Kitna hai proton ka mass? Anybody can tell me the mass of proton? Yes. Yes. What is the mass of the proton? I told you before.
1.626 into 10 to the power 27
10 to the power?
minus 27
Very good. Unit कौन सा है?
gram
That is equal to 1.6 into 10 to the power
minus 27 gram.
minus 27 grams. Very good. Minus 27 grams. 10 to the power minus 27 gram. This is the mass of the proton. इसीलिए एटम्स के जो एटॉमिक मास थे वो उसके एटॉमिक नंबर से डबल थे, राइट? दे आर हैविंग द डबल मास rather than the top their mass of their atomic number. Have you got this one? समझ में आया अभी? It is a means neutron is it's chargeless particle. It is chargeless particle. And here it is having the same mass as that of the proton, which is having the mass 1.6 into 10 to the power minus 27 gram. अब हमें एटम का स्ट्रक्चर किस तरह से पता है? How is the atomic structure is there? How is the atomic structure? How is the atomic structure? Atomic structure. Here atom is containing the nucleus, right? Atoms are divided into the two parts. First one, it is nothing but the nucleus. First one, it is called as a nucleus. What the nucleus is containing? It contains protons and neutrons within it, right? These are also known as nuclear particles. These are also known as the nuclear particles. इसे न्यूक्लियर पार्टिकल्स भी बोलते हैं. जो कि न्यूक्लियस में पार्टिकल्स होते हैं उन्हें बोलते हैं न्यूक्लियर पार्टिकल. And second half of the atom, it is nothing but the orbits or the energy shells, right? Orbits. Atom is containing the orbits or it is containing the energy shells in which electrons are revolving. Are revolving around nucleus, right? इस तरह से हमें अब एटॉमिक स्ट्रक्चर इस तरह से होता है, ये अब हमें पता है. अब हम देखेंगे कि हाउ द इलेक्ट्रॉन्स आर डिस्ट्रीब्यूटेड in these orbits or the energy shells. That distribution of the electron is known as the electronic configuration. It is known as the electronic configuration. उसे क्या बोलते हैं? It is known as the electronic configuration, right? Electronic configuration. What is meant by the electronic configuration? That is nothing but distribution of electron in the electronic orbitals or energy shells is known as electronic configuration. Is known as the electronic configuration. Now, how it is to be get divided? See here, we have to discuss. There are some rules. What are these rules? Now, see, for these rules, you must understand that. Remember the first one rule. Electrons first occupy lowest energy level or shell. Lowest energy level or the shell, right? Second rule, it is that outermost orbital of an atom is known as valence orbital should occupy 8 or less than 8 electrons in it, right? 8 or should occupy 8 or less than 8 electrons in it. These are the two rules. For the second rule, there is exception. There is some exception is there. Exception, the atoms like as hydrogen and helium have first orbital as valence orbital. Hence, it can occupy 2 or less than 2 electrons only. 2 electrons in it. You follow this one? कितने maximum occupy करेगा? 2 or less than 2 electrons in it. Have you followed? Rules समझ में आए हैं आपको? Yes, children? Yes. I want answer from you.
Yes, sir.
क्या है first rule? पढ़ो तो जरा. What is the first rule? Yes, what is the first rule? Electrons first occupy lowest energy level or the shell. Outermost orbital of an atom is known as valence orbital, should occupy 8 or less than 8 electrons in it. समझ में आया ये?
नहीं
अब
मैम।
हमें ये पूरा इलेक्ट्रॉन डिस्ट्रीब्यूशन देखने से पहले हमें 2 टर्म्स पता होने चाहिए, जिन्हें बोलते हैं एटॉमिक नंबर. ये जो एटॉमिक नंबर है, दिस एटॉमिक नंबर इट इज डिनोटेड बाय लेटर Z. कौन से नंबर से दिखाई देता है? Z. इट इज डिनोटेड एज Z. It is a symbol for the atomic number. See the definition for the atomic number. The total number of protons present in an atom, present in an atom is known as, is known as, is known as its atomic number, is known as its atomic number. Now we have to discuss that what are the significance of this atomic number. Means what are the characteristic properties, what are the significance of atomic number. Children, mute yourself.
कौन कौन
See here, the first significance is that atomic number indicates, atomic number indicates total number of protons present in an atom as atomic chargeless, atomic chargeless. It has equivalent, or you can say it has same number of electrons, same number of electrons in it. It has same number of electrons as protons, as number of protons, as number of protons in it. Right? Means atom is having the same number of the protons and same number of the electrons. That is, ultimately, atomic number shows the total number of electrons present in an atom, present in the atom. Have you followed this one? समझ में आया? एटॉमिक नंबर क्या दिखाता है? नंबर ऑफ प्रोटॉन्स. लेकिन एटम कैसा है? चार्जलेस है. और वो चार्जलेस होने के कारण उसमें जितने प्रोटॉन्स है उतने ही क्या है यहाँ पे इलेक्ट्रॉन्स है. राइट? उतने ही क्या है यहाँ पे इलेक्ट्रॉन्स है. राइट? यहाँ पे जितने प्रोटॉन्स है उतने इलेक्ट्रॉन्स है. यानी कि हमें ये कह सकते हैं कि एटॉमिक नंबर हमें इलेक्ट्रॉन्स भी, नंबर ऑफ इलेक्ट्रॉन्स भी दिखाता है. अब सेकेंड सिग्निफिकेंस क्या है एटॉमिक नंबर का? नो two elements have same atomic number. इसका मतलब क्या है? That is, every element has unique atomic number. When atomic number changes, element change in element occurs. Change in element is observed. Right? अब इसके एग्जाम्पल देती हूँ मैं आपको. Which change in element is ऑब्जर्व। अब देखो इसके कुछ एग्जांपल्स देती हूँ। एग्जांपल, हम यहाँ पे कुछ एलिमेंट लेंगे और उसका क्या करेंगे, यहाँ पे we will have to discuss regarding the some of the name of the element and that of the name of we are going to discuss regarding the name of the element. एक टेबल इंसर्ट करती हूँ, कॉलम्स 2 होंगे इसमें। Number of the rows.
मैम फर्स्ट पेज पर से दिखाओ।
हाँ, what
First-
happened?
फर्स्ट पेज शो रिपीट।
What I have to repeat?
फर्स्ट पेज शो रिपीट।
First page. Hold
Yes.
the first page.
हाँ ये
I have already taught this one. Up to this, I have already taught regarding the energy levels of the energy shells, right? Then after
Yes.
we have seen that Bohr's atomic model is to be given in the year 1913. At that time, only two subatomic particles are known, protons and electrons. But in the year 1932, James Chadwick has discovered the third subatomic particle, and it is known as a neutron. What is the specificity of the neutron? Neutron is a chargeless particle and it is having the same mass as that of the proton, which is equivalent with 1.6 into 10 to the power minus 27 gram. Then after here, nowadays we know the atomic structure. Actually, the atomic structure is divided into the two parts. First, it is nothing but the nucleus, and second one, it is nothing but the orbits or the energy shells. Nucleus, it contains the two particles within each one, protons and neutrons, and these particles are also known as a nuclear particles. Orbits, they are having the electrons are revolving around the nucleus in these orbits. Now, how these electrons are to be distributed within this orbit, that process of distribution of the electron in this orbit, it is known as the electronic configuration. I have given definition for the electronic configuration as distribution of electron in the electronic orbit or energy shell. It is known as the electronic configuration. उसके लिए हमने दो रूल्स देखे। फर्स्ट वन रूल देखा, इलेक्ट्रॉन्स फर्स्ट ऑक्यूपाई लोएस्ट एनर्जी लेवल। सेकेंड रूल देखा, outermost orbital of an atom is known as the valence orbital and it should occupy 8 or less than 8 electrons in it, not exceeded than that of the 8 electrons. Here two exceptions are there. The atoms like as hydrogen and helium have first orbital as a valence orbital, which is the outermost orbital of these atoms, and hence they can occupy 2 or less than 2 electrons within each one. Now, after that, before we see the examples for the electronic distribution, you must know regarding the atomic number. Atomic number means it is nothing but the Z. What is meant by the Z? That is nothing but the total number of the protons present in an atom. It is known as the atomic number. What are the significance of the atomic number? What is the speciality of the atomic number? That I am going to discuss. Atomic number indicates total number of protons present in an atom. As atomic chargeless, it has same number of the electrons as that of the number of protons, right? That is ultimately we can say that atomic number shows the total number of electrons present in the atom, right? In atom only. I'm talking about only the atom. Now, second one, that is nothing but no two elements have same atomic number. That is, every element has unique atomic number. When atomic number changes, change in element is observed. अब उसके examples दे रही हूँ. Have you got this one? समझ में आया क्या? अब मैं इसके examples दे रही हूँ. यहाँ पे I am writing the name of element. I am writing name of element. And the second thing, I am writing their atomic number. Atomic number, right? I'm writing the atomic number within each one. Now see, first element, that is known as the hydrogen. You have to learn all these elements. Atomic number of the hydrogen is 1. Second element, it is with the helium. Helium, it is having the atomic number 2. Its atomic number is 2. Now I'm writing one by one here. Just a minute. Hydrogen, helium. Now I'm writing here one by one. 3, then 4, then 5, then 6, then 7, then 8, then 9, then 10, then 11, then 12, then 13, then 14, then 15, then 16, then 17, then 18, then 19, and then you have to remember up to 20. Okay, now I'm writing the name of these elements. First is the hydrogen, second it is nothing but the helium. Third one, it is known as a lithium. Third one, lithium. Fourth one element having the 4 number, beryllium. Fifth one, boron. Sixth one, carbon.
Nitrogen.
Nitrogen, very good. Seventh one is the nitrogen, which is
Oxygen.
the eighth one. Eighth one is the oxygen, very good. Next one,
Fluorine.
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 Fluorine,
Sodium.
Neon.
Neon.
neon. अरे neon is बीच में क्यों आ गया?
Sodium.
NeON.
I know the spelling. I'm taking them little bit there. Now 11.
Sodium.
Sodium.
उसके बाद है मैग्नीशियम.
Magnesium. Magnesium. Magnesium.
मैग्नीशियम. मैग्नीशियम के बाद में है एल्यूमिनियम.
Silicon.
उसके बाद में है
Silicon.
उसके बाद में है फॉस्फोरस.
Phosphorus.
फॉस्फोरस. उसके बाद में है सल्फर. उसके बाद में है
Also.
वेरी गुड.
Argon.
अर्गॉन. उसके बाद में है पोटेशियम.
Calcium.
कैल्शियम. और 20 क्या है? कैल्शियम. वेरी गुड. Calcium. Now here I am writing their symbols also. Calcium Ca, it is the symbol. For potassium, symbol is K. For argon, symbol is Ar. For fluorine, symbol is Cl. हाँ, कैपिटल C स्मॉल l. उसके बाद सल्फर के लिए सिंबल है कैपिटल S. उसके बाद में फॉस्फोरस के लिए सिंबल है कैपिटल P. उसके बाद में सिलिकॉन के लिए सिंबल है Si. उसके बाद में एल्यूमिनियम के लिए सिंबल है Al, कैपिटल A स्मॉल l. Write in the same manner as I have written on the screen. मैग्नीशियम के लिए सिंबल
mg
स्मॉल जी,
mg
small capital M, small g. Don't write both capital. For sodium,
Na.
symbol capital N, small
na
a. Capital N, small a. For neon, it is capital N, small e, neon.
n
For fluorine, it is
F
having
capital F.
symbol capital F. For oxygen, it is having the
Capital
symbol capital O. For nitrogen, it is having the
F.
symbol capital N. For
Capital
carbon,
capital
it is
N
having the symbol capital C. It is having the
c
capital C. Boron, it is having the symbol capital B. Okay. Then next one, it is nothing but for
capital B.
beryllium.
Small e.
It is having the symbol capital B, small
Small
e. For lithium, it is having the symbol capital L, small I. For helium, it is having the symbol capital H, small e, right? And here for hydrogen, it is having the symbol
H
capital H. And for this one, these are nothing but the atomic number, and these are the elements. समझ में आया?
yes ma'am
Now see, in this case,
yes ma'am
these are nothing but the, means we can write from here how many number of the proton and electron does these atoms are having, as their atomic numbers are same, right? Their atomic numbers are their atomic number, as per their atomic number, they are having the similar number of the protons and similar number of the electrons within each one, right? They are having the similar number of the protons and similar number of the electrons. अब हम देखेंगे इस साइड में कुछ इंसर्ट हो सकता है क्या, इंसर्ट का है क्या कुछ insert. हाँ, अब देखो यहाँ पे हमने एटॉमिक नंबर लिख दिए, तो हम यहाँ पे ये भी लिख सकते हैं क्या, नंबर ऑफ प्रोटॉन्स, नंबर ऑफ प्रोटॉन्स। यहाँ पे हम क्या लिख सकते हैं, नंबर ऑफ
न्यूट्रॉन।
इलेक्ट्रॉन्स। नहीं बेटा, न्यूट्रॉन नहीं, इलेक्ट्रॉन लिखेंगे फिर। न्यूट्रॉन का तो मैंने बताया भी नहीं आपको। राइट, अब देखो एटॉमिक नंबर जितना है उतने ही क्या आएंगे, नंबर ऑफ प्रोटॉन्स और नंबर ऑफ इलेक्ट्रॉन्स। समझ में आ रहा है, क्योंकि ये एटम्स है, राइट। जितने नंबर ऑफ प्रोटॉन्स है उतने ही नंबर ऑफ इलेक्ट्रॉन और क्या हो जाएंगे, नंबर ऑफ प्रोटॉन्स हो जाएंगे। हैव यू फॉलोड दिस वन? समझ में आ रहा है क्या? ये टेबल कंप्लीट कर सकते हो आप लोग?
यस मैम।
कर दो फिर, मैं तो एक मिनट में कर देती हूँ। आया क्या समझ में? आपको ये भी दे दूं क्या, 21 और 22 वाला एलिमेंट? शैल आई गिव यू
yes
फॉर
ma'am
21? ओके, दे देती हूँ, उसका भी नाम दे दू फॉर यूर सेक ऑफ कन्वीनियंस, मोर अंडरस्टैंडिंग। एक्चुअली 22 तक के एलिमेंट आपको याद रखने की जरूरत नहीं है, 20 तक भी रखेंगे तो बहुत होगा। 20 वाला एलिमेंट है कैल्शियम 21, इट इज द स्कैंडियम।
कैंडियम
स्कैंडियम इसका नोटेशन है कैपिटल एस स्मॉल सी। और 22 वाला टाइटेनियम।
TA.
टाइटेनियम इसका सिंबल है कैपिटल टी स्मॉल आई। Okay, these are the elements and these are the number of electrons and protons present within each one. I followed up to this one. समझ में आया एटॉमिक नंबर क्या है और इन एटॉमिक नंबर के सिग्निफिकेंस पता चले आपको। मैंने जो सिखाया आप लोगों को वो देखो, एटॉमिक नंबर जैसे बदलता है एलिमेंट का नाम भी बदलेगा। व्हाट दिस वन, समझ में आया क्या?
यस मैम
यस चिल्ड्रन, समझ में आया? नाउ सी आवर मीटिंग टाइम इज गोइंग टू बी ओवर। आई वांट टू स्टार्ट। कौन है ये? ट्विंकल, यू डोंट गेट? यस ट्विंकल,
मैम
क्या नहीं समझा बेटा आपको?
समझा मैम।
समझा ना, आपने चैट किया है मैम नहीं समझा, इसलिए मैं
मैम
बोल रही हूँ।
पहले नहीं समझा था, अभी समझ गया।
समझ गया? अश्विन, हैव यू अंडरस्टूड व्हाट
Yes,
इज मीन
ma'am.
बाय दिस वन? व्हाट आर द सिग्निफिकेंस ऑफ द एटॉमिक नंबर? समझ में आया एटॉमिक नंबर क्या है?
Yes, ma'am.
Okay, beta. Now here I am going to conclude the meeting so that I want to start with the other meeting also. Have you followed this one? समझ में आया क्या? लिख लिया ये सब कुछ जो मैंने आपको लिख के दिया था वो? Yes, children.
यस
First page फिर से दिखाना है. Okay, I will show you the first page. Back again. See. आपको क्या स्क्रीनशॉट? चिल्ड्रन लिसन, अवॉइड टू टेक द स्क्रीनशॉट। स्क्रीनशॉट लेना अवॉइड करो। ये देखो, आप लोग अगर मेरे सिखाते वक्त अगर आप लोग लिखते हो तो आपको रिवीजन की भी जरूरत नहीं पड़ेगी। यस, शैल आई स्टॉप द शेयरिंग? आप लोग थोड़ा सा पेन लेके हाथ में बैठा करो, ये मत करो इस तरह से। स्क्रीनशॉट लेना छोड़ दो। स्क्रीन शॉट से सिर्फ आपके मोबाइल की या लैपटॉप की मेमोरी फुल हो जाएगी, आपके मेमोरी में कुछ भी नहीं आएगा। ओके ओके, now I'm going to end the meeting. We will meet tomorrow at evening only. Okay.